On number 2, I'm trying to solve by completing the square. And my first step for completing the square is I want the x squared term and the x term on one side and the constant on the other. So I'm going to add 8x to both sides and leave a space and then set it equal to 5. So now I want to figure out my two numbers for completing the square. The first number is half the coefficient of the x term, or half of b. So half of 8 would be 4. My second number is I want to square this number that I found. So 4 squared is 16. And that's the number I'm going to use first, but it's going to be helpful to have this 4 written down here because we will see it later. So I want to add 16 to both sides, and this will be x squared plus 8x plus 16 is equal to 21. Now the left-hand side turns into x, and then this is where I see that first number, that 4. It'll be x plus 4 squared is equal to 21. And that's because this left-hand side factors as a perfect square trinomial. It factors into x plus 4 times x plus 4, or we write it as x plus 4 squared. But you don't even really need to think about it as factoring. You just need to think about it as x and then whatever this number is, and then squared. Okay, so now I want to get rid of that square by using the square root property. And that's going to give me x plus 4 is equal to plus or minus square root of 21. And then I want to subtract 4 from both sides. So x is equal to negative 4 plus or minus square root of 21. And I can't simplify the square root of 21, so this is my answer. If you wanted to write out both answers separately, it would be negative 4 plus square root of 21 and negative 4 minus square root of 21. So just a couple more things about this problem. If you wanted to check your work, you could. You would just have to plug these into the original. And it could take a long time because you need to type in negative 4 plus square root of 21 in parentheses squared, and then also plug it in with the minus 8. So it takes a while, but you can check them. And then another thing is that there's really no way we could have gotten this answer by just factoring. So you'll remember from the previous chapter, we were trying to solve some equations by factoring, and we couldn't factor. So there are many trinomials which can't be factored. And what do you do when that's the case? Well, you use completing the square, because completing the square is able to get you answers like negative 4 plus or minus square root of 21, whereas factoring can't do that.